Hello everyone, welcome back. We're going to continue our discussion of the Huntington Hill method, and today what we're going to do is we're going to take a look at the Huntington Hill method side by side with the Webster's method so that we can see the difference specifically in how we round those quotas. Alright, so we're going to start here with example 9. We've got a small country with 5 states, 2 of which are much larger than the others. So we have 2 states that are considered high population states and the rest which are considered low population states. Alright, we're going to apportion 70 representatives, and we're going to apportion both using both Webster's method and Huntington Hill. All right, now both methods start off the same exact way. The first thing we need to figure out is a divisor. So if I take these populations and I add them all up, we're going to get 610,000 total people, and I'll take that 610,000 people and I will divide it by the 70 representatives that we need to apportion, which is going to yield a divisor of 8,714.286. Okay, so this becomes our divisor, and we're going to use this divisor in both Webster's and the Huntington Hill method. So we're knocking out 2 birds with 1 stone here. All right. Now the next thing that we're going to calculate are the quotas, and again, these quotas are going to be the same for both methods. You're going to do it in both methods. So we're going to take each individual population and divide it by our divisor. All right, so now I have my quotas. We're going to be using these quotas twice, one for Webster's and one for the Huntington Hill method. All right, so let's do Webster's first. We'll do Webster's method first. And remember that Webster's method, what we're going to do with these quotas is we are going to round, and we are going to round based on 0.5. Okay, so whether or not a quota is going to go up to 35 or stay at 34, it's going to be based on 0.5. So whether or not this decimal portion is bigger than 0.5 or smaller than 0.5. So initially here what we have is a number that is below 0.5, so this is going to stay at 34. This one being 0.95 is higher than 0.5, so this one is going to go up to 23. This one is higher than 0.5, so it's going to go up to 6. This one is lower, so it'll stay at 4. And this one is lower, so it will stay at 2. Then we go through and we make sure that we add up this initial apportionment. And remember, we needed to apportion 70, but if we add these up, we are only going to get 69 members apportioned. So that's not enough. All right, so if we only apportion 69, that means we didn't apportion enough, so we're going to have to adjust the divisor down. So if you get too few, you move the divisor down, and we're going to move it down to 8,700 and recalculate our quotas. So I'm taking my individual populations and dividing by my modified divisor of 8,700. All right, so I've got my quotas here. You'll notice that they are slightly different from the quotas that we had up here due to our modified divisor, but now we're gonna do Webster's method here, where we're gonna round based on 0.5 one more time with our new quotas here. So 34.5402, that's gonna round up to 35. The 22.9885 will round up to 23. This one will round to 6, 4, and 2. And when I add those up, we get 70 representatives apportioned, which is exactly what we needed. So this modified divisor worked for us and got us the apportionment that we needed. Okay, so notice from our initial apportionment to our final, the state that got that bonus representative, if you will, was the large population state, right? State A with the largest population ended up going from 34 to 35, while everyone else stayed the same. All right, so now we're going to switch over to the Huntington Hill method. All right, so remember, our divisor and our quotas were the same as before, right? So I just copied down the quotas. And Huntington Hill, remember, rounds based on the geometric mean. Okay, so we're not using 0.5 anymore to determine how something rounds. We're using the geometric mean to determine how something rounds. So we've got to find this thing called a lower quota and also its upper quota. All right, so the lower quota here would be 34, which means its upper quota would be 35. So this one would be 22 and 23. This one would be 5 and 6, 4 and 5, and 2 and 3. All right, and we use these numbers to calculate our geometric mean. So first we multiply and then square root. And we're going to do that for each pair of numbers that we put in here. So multiply and square root. So let's figure out what our geometric means are. All right, so I got my geometric means here, and now we're going to round based on these numbers. So if our quota is smaller than the geometric mean that we calculated here, it's going to stay with the lower quota. However, if it was bigger, then we would go to the upper quota. All right, so 34.483 is smaller than the 496 here, so this one's going to stay at 34. This one here, we got 9.5, which is bigger than 4.9, so this one's going to go up to 23. And 5.73 is bigger than 5.47, so this one's going to go up to 6. And this one, 4.36, is smaller, so this one's going to stay at 4. And this one, the 4.67, is bigger than the 4.495, so this one's going to go up to 3. So this is 34, 23, 6, 4, and 3. And when I add all of those up, we get a perfect 70 representatives, which is great because we don't have to go back and modify the divisor and do all of this again. All right, this is one of the drawbacks of those modified divisor methods, is that sometimes you do and it's tedious and it's not fun. All right, and there's no way around it. Unfortunately, it is part of the process. All right, so we got our 70, which is good, but notice who got the bonus representative here. All right, so that bonus representative went to our small population state, and this is where the battle rages, right? So the battle has always been between the big states and the little states, and every single one of these states trying to jockey for power and position in the House of Representatives, and also with the number of electoral votes that they get in a presidential election. Right? You want more votes, you want more representation in that House, so they're always going to argue for the method that benefits them the most. Ironically, a lot of the states that used to argue for the methods or used to advocate for the methods that favored high population states, such as Webster's and Jefferson's method, are no longer high population states today. They're actually considered some of the lower population states and would be better served by a method like Hamilton's or Huntington Hill. So the hypocrisy reigns supreme, as always. Depending on who you are and what your situation is, you are always going to go for the method that gets you the most votes. That's just what they do. All right, but we currently use the Huntington Hill method. It has shown a lot less bias towards the large population states. So it's a good method. It's been tried and true for some time now. All right, guys, that's it for today's lesson. Give the practice problems a try. Make sure if you're struggling with this Huntington Hill method, you ask me some questions in the Zoom chat. Have a great day.